Today's learning target is I can solve problems involving the perimeter and area of triangles and rectangles. If you remember from previous years, when you find the perimeter is the distance around an object. Okay, so here we've got a triangle and a rectangle. So if we're asked to find the perimeter, we're looking for the distance around it. To find the area of a rectangle, I could use this formula. Perimeter equals length plus width plus width. Or I could do perimeter equals 2 times the length plus 2 times the width. Or I could do 2 times the length plus the width. So any of these three formulas will give me the perimeter of a rectangle. If I'm looking for the perimeter of a triangle, I am left with the perimeter equals the A plus B plus C. Okay, I just have to add those. There's no other way to do it. Today we're going to be using the formulas for perimeter to help us solve problems. So here we have an example. It says the perimeter of a rectangle is 42 feet. Its width is 10 feet. Find the length. Now it might be that you can solve this problem in your head. However, today we're going to use the formulas to help us solve problems like we see today. Because pretty soon you're going to get to problems where you can't solve them in your head, so you have to know how to solve those types of problems. So step one is going to be to write out the formula that you're going to use to solve it. Either one of these would work. Step two is going to be to plug in our numbers. So I see here that the perimeter is 42 feet and the width is 10 feet. So I'll plug those into my formulas. So in both of these formulas, I plugged in 42 for the perimeter and I plugged in 10 for the width. And now I'm just solving the equations. So if I start on the left here, I'm going to go, I know this is 20 plus 2L, that equals 42. Now I subtract the 20 because I want to get rid of the things that are not attached to the variable. That leaves me with 22 equals 2L. And now I divide by 2 on both sides, and I get L equals 11. Okay, that's just like the two-step equations you solved before. Now if I was using this formula this way, okay, I know here, first thing I have to do is use the distributive property to rewrite this. So I'd get 42 equals 2L plus 20, and now it's exactly the same as this problem. So if you remember from years past, when you find the area of an object, you're finding the amount of space inside of something. Okay, and so we measure that in square units. So in this case, this figure right here, the area would be 16 square centimeters because there's 16 of these, 16 squares, and they're a centimeter on each side, so they're square centimeters. Now you probably remember from years past that to find the area of a rectangle, you take the length and you times it by the width. And if you remember to find the area of a triangle, you're going to take 1/2 of the base of the triangle, which is the bottom, and times it by the height. If we look at this picture of the triangle right here, we can see why we use that formula. So there's our triangle. Okay, so the base of that triangle is right here. The height of this triangle is right here. Now if we put another triangle exactly the same along that triangle, we now have a rectangle with the length and the height. But the triangle, our original triangle, is half of that rectangle. So that gives us 1/2 the base times the height. So today, for any of the problems that you solve, there are going to be 3 steps. The first is going to be to write down the formula. The second is to plug in the numbers. And the third step will be to solve. So if we take a look at this problem here, it says the base of a triangle is 12 inches. Its height is 5 1/4 inches. We're looking to find the area. So step one, I'm going to write down the formula for finding the area of a triangle. So I know the area of a triangle equals 1/2 base times height. Step two is I'm plugging in the numbers. So the base right here was 12 inches and the height right here was 5 1/4 inches. And now I'm going to solve. And now I remember from multiplying fractions here, I want to change any mixed numbers into improper fractions. So here 4 times 5 is 20, plus 1 is 21/4. So I'm going to change this to 21/4. Okay, and I know 12 is 12 over 1, and times that by 1/2. And now I simplify. Okay, remember that's the first step before you multiply across. So when I do that, I see I have even numbers here and here. 2 goes into both those, 1 time and 6 times. And here's a 4 and a 6, so those are both even. 2 goes into there twice, 2 goes into there 3 times. And now when I multiply the numerators, I get 3 times 21. It's going to give me 63. And my denominators, when I multiply those, I'm going to get 2. And now I'm left with 63 over 2, or 63 halves. And if you remember, to turn an improper fraction into a mixed number, we just divide it out. It's 63 divided by 2. And when I do that, I get 31 with a remainder of 1, which means I get 31 and 1/2. And now I want to think about what is my label going to be. So I'm looking at the area equals 31 1/2, and I'm dealing with inches, and I know area is always in squares, so I would put inches, and you could put a little 2 up there for squared, or write out inches squared. You could also flip that and say 31 1/2 square inches. Either one is fine.